Now let's discuss about the characteristics of transistor connections. Characteristics means it is the graphical representation of the interrelationship between the voltages and various currents in a circuit. The complete electrical behavior of a transistor can be described by stating the interrelationship of various currents and voltages, and these interrelationship of currents and voltages can be conveniently represented graphically, and the curves obtained thus are called characteristics of a transistor. And we can have generally we will discuss about three types of characteristics, that is if we study the input and voltage and input current, the relation between the input voltage and input current, we call it as the input characteristics. And if we study about the output voltage and output current, we call it as the output characteristics. And also for the practical purposes, we will consider one more characteristics, that is called transfer characteristics, which represents the variation of the output current with the input current. So transfer characteristics represents the variation of the output current with input current. The input characteristics represents the variation of input voltage with input current. The output characteristics represents the variation of the output current with the output voltage. So we can say that the vi output vi characteristics is called output characteristics, and the transfer characteristics means it is the relation between the graphical representation of the relation between the output current and input current. So now we will see one by one. So first of all, consider the input characteristics of a common base connection. In the case of a common base connection, the input voltage is the base emitter voltage. Since base emitter junction is the input terminal, so we can call the input voltage of the common base as VBE, the voltage across the base and emitter, which is called the base emitter voltage. Now the input current is the emitter current in the case of a common base connection, so it is represented by IE. So now the variation of the input characteristics of a common base connection can be defined as the graphical representation of the base emitter voltage and emitter current, keeping the collector base voltage constant, that is output voltage constant. So keeping VBC constant, what if we draw the variation of the base emitter voltage with the emitter current, we can have the input characteristics of a common base connection. And this diagram represents the input characteristics of a common base configuration. And the 2 points we can be noted from these characteristics. The first one is the emitter current IE increases rapidly with a small increase in base emitter voltage VBE. That is, if we increase the base emitter voltage very small, then there is a rapid increase in the emitter current, which means that that is, if the emitter current increases rapidly with increase in base emitter voltage, we can say that input resistance is very small. And the second one, The emitter current is almost independent of the collector base voltage that you can see here. If you consider the variation of IE with VBE or VEB, the VCB, if you take VCB as 0 volt or 10 volt, the variation or the dependence of IE on VB are almost the same. There is no much difference in the variation of IE with VBE for different values of VCB. So we can say that IE, the emitter current IE, is almost independent of base collect VCB, that is collector base voltage. So these are the two important things which we can get from here. And one more thing is the expression for the input resistance. So if we consider the input resistance is we denote it by Ri, which is equal to ratio of the change in input voltage, that is VBE, divided by delta IE, that is change in input current. Resistance is ratio of voltage to current, so here the input resistance is the ratio of the change in input voltage to change in input current. So here Ri is equal to the input resistance of a common base configuration or common base connection is given by Ri is equal to delta VBE divided by delta IE at a constant VCB. At constant VCB. Now let's discuss, this is about the input characteristics. Now let's discuss about the output characteristics. So again, have a comparison with these terminologies. Input characteristics means the variation of the voltage with current. Input characteristics means variation of the input voltage with the input current, keeping output voltage constant. So definitely output characteristics will be the variation of the output current with the output voltage. Here we are keeping the emitter current constant, because the small variation in the emitter current will make a large variation in the collector current, since we know that IE is equal to IB plus IC. In IB, in that expression, IB is very small, so IE can be approximated to IC, or IEC will usually of 95% of IE, the emitter current. So a small variation in the IE, the emitter current, will reflect as a large variation in the collector current. But in the output characteristics, we have to consider only the variation of the collector current with only the output voltage, or the output current with the output voltage. So we will consider, in the case of output characteristics of a common base connection, we have to consider the output variation of the output current, that is denoted by IC, with output voltage, that is VCB, keeping the emitter current constant, that is at constant IE. So output characteristics of a common base configuration can be defined as the graphical representation of the variation of collector current with a collector base voltage at a constant emitter current. Now you can, from this diagram you can see the variation, the output characteristics of a common base connection. Here the x-axis, we are taking the collector base voltage along the x-axis and the collector current along the y-axis. And you can see that the collector current IC varies with VCB only at very low voltages. Usually it is less than 1 volt only. IC as a variation with VCB. When beyond that value, that is if the collector base voltage is greater than 1 to 2 volts, the IC does not have any dependence on the collector base voltage. The collector current is almost constant for any values of collector base voltage. So that means in these two conditions, first condition, that is collector current has a small variation with a collector base voltage, and usually the transistor is never operated in this region, and we will never operate in this region, and the operating region of a transistor, or in almost all purposes of common emitter connections, we will operate the transistor only for the values which is collector current is independent of the collector base voltage. And we can say that a large variation of or large change in the collector base voltage will produce only a very tiny change in the collector current. That is, if you consider this diagram, you can say that this is almost constant. There is much change in the collector current. So we can say that the variation of the collector current with collector emitter voltage is almost zero or very small. So we can say that the collector base voltage for a large change in VBC will have a tiny change in collector current, so the output resistance is very high. We can say that since the resistance is very high, that's why there is a small change in current even though there is a large change in the voltage. So that is the another thing which we can note from the output characteristics, is that the output voltage is very high. Now let's see what is the expression for the output current. So the output current we are output resistance. So we are representing the output resistance by R0, which is equal to the change in the output voltage to the change in output current. So here the output voltage is the collector base voltage VCB divided by delta IC at constant. Remember that the constant which we are keeping here is the emitter current IE. So at constant IE. So this is the expression for the output resistance of a common base configuration. Thank you.